Hi, I'm Burt Monroe from Penn State University, and I'm here to present work with my colleague Eric Plutzer on measuring the validity of open-ended questions. We're increasingly seeing open-ended questions, particularly in large surveys, in part because of work in computational social science to develop Texas data methods for analyzing open-ended text. Exercises like classification can be validated in the machine learning sense, but there are conventional survey concerns of data quality, the validity of the questions themselves, that are more difficult to address. We have ways of quantifying certain types of validity in closed-end questions, but these have been limited largely to broad indicators of quality like number of items left blank or length of answers. Today we're going to introduce a method for measuring convergent and discriminant validity of open-ended questions using the text of their answers. A question shows discriminant validity if respondents answer it differently than they answer questions intended to measure different constructs. Conversely, a question has convergent validity if respondents answer it similarly to how they answer questions intended to measure similar constructs. And more subtly, questions intended to measure more similar constructs should evoke more similar answers. We're going to leverage a natural language processing technique called Fightin Words to quantify the dissimilarity between two collections of answers to leverage for this test. We're going to apply a randomization technique to establish a reference distribution of the Fightin Word statistic under the null that for any pair of questions, differences in the questions do not induce different answers. The data we'll be using are drawn from the Mood of the Nation poll, which is run by Penn State's McCourtney Institute for Democracy. We're using 13 waves, independent samples from YouGov's non-probability panel, with field dates from June 2016 through January 2020. Each survey contains 1,000 respondents, giving us a preliminary sample size of 13,000 respondents. For each respondent, the poll asks 4 open-ended questions about what makes them proud, angry, worried, and hopeful, giving us a preliminary sample size of 52,000 open text answers. Half of the respondents are asked, what is there about American politics today that makes you feel angry and proud? The other half are asked, what has recently been in the news that makes you feel angry or proud? All respondents are asked the worry and hope questions in the form, looking ahead, what makes you worried or hopeful about where America is headed in the next 12 months? So this gives us 6 question variants in the poll. All 1,000 respondents are asked what makes them angry, proud, worried, and hopeful. Half of the respondents under the angry and proud questions are asked to contemplate recent news or politics. So each emotion question can be contrasted with 3 corresponding questions. One that differs in polarity is positive rather than negative. One that differs in temporal orientation, that's future-oriented rather than present-oriented. And one that differs in both. Similarly, each pride or anger question can be contrasted with 3 corresponding questions. One that differs in emotion, whether it's proud or angry. One that differs in contextual prompt, whether it's about news or politics. And one that differs in both. To represent our text, we use a bag of words representation. That is, we consider words and tokens more generally in isolation as opposed to concerns about sentence syntax and grammar. The raw data, which is entered by the respondents themselves, has many mistakes. For our analysis here, we use a processed version of the responses, which includes some standard NLP preprocessing like case folding and removal of most punctuation, but also some handcrafted processing, correcting spelling, and particularly disambiguation and standardization of references to specific people and other multi-word entities, like Donald Trump or Supreme Court. The basis of the method we'll show today is a technique called Fightin Words, which is an NLP technique for evaluating how word usage differs across 2 or more groups of documents. We use the primary output of the Fightin Words technique, zeta, which provides us with a quantity for each word that indicates the extent to which it is overused or underused by the target group relative to how unexpected this disparity is for the particular word. We call this the FW statistic. The FW statistic is in effect a conservative z-score and can be interpreted as such. That is, absolute values of roughly 2 or more indicate a significant difference in usage across the groups, and greater values indicate greater importance. A typical usage of the Fightin Words technique is to identify words that differ by party. So here we see in an example from the original paper, partisan differences in congressional speech on the topic of abortion. Here we use the Fightin Words technique to distinguish between two distinct questions. In this example, you see the 10 most extreme values in the contrast between the angry question with the news prompt and the proud question with the news prompt. Recall that for our examination of validity, we'll need a measure of dissimilarity. If two groups of documents are in fact the same, drawn from the same distribution, we expect the FW statistic to be distributed like a conservative z-score. That is, normally distributed with a mean of 0 and a variance somewhat smaller than 1. As the differences grow between two groups of documents, increasingly more words will have FW statistics that are increasingly far from 0, and there will be greater variance in the distribution of the FW statistic. So we will use the variance of the FW statistic, which we will call FW variance, as an indicator of dissimilarity between the answers to two different questions. Recall our definition of discriminant validity, that any two questions intended to measure different constructs display discriminant validity if they evoke different answers. This implies the null hypothesis that answers do not differ, that the distribution of answers observed for each of the two questions does not depend on which of the questions was asked. This suggests a randomization test or permutation test can be used to establish the baseline distribution, how much variance in the FW statistic could be expected if the questions did not matter, by randomly redistributing the question labels among the observed answers and observing the distribution that results. So this illustrates the process. We can calculate the observed FW variance by taking our original answers, grouping them by the question stem, in this case angry and proud, into one aggregate text, processing and getting the FW statistics, from which we then calculate the FW variance as our measure of distance. For our randomization test, we randomly permute the question labels across the observed answers, reaggregate on those new artificial categories, recalculate our FW statistics, and recalculate our variance. We repeat this many times with many random permutations, and this gives us a null distribution under the assumption that the question labels did not affect the answers. We can compare the observed FW variance with this null distribution, comparing against, for example, the 99th percentile. This table shows the results of the discriminant validity test on all pairs of emotion questions for the September 2019 wave of the poll. We see comparisons between questions that differ in just temporal perspective, just polarity, positive, negative, or both. And we see that the observed FW variance is in fact much greater than even the 99th percentile of the null distribution, indicating the differences in the answers observed are very unlikely if the questions did not matter. Here we see those same results summarized for all 13 waves of the poll. This is specifically the contrasts of angry, and discriminant validity in this case requires that these observed levels in the contrast, this is angry versus worried, angry versus proud, and angry versus hopeful, that these appear higher than the null, which they clearly do in all 13 waves. Similar pictures for the other three emotions and all their contrasts over all waves are provided in the paper and in extra slides attached to the slide deck. Should note that the null variance distributions show a lot of consistency, but they are not mathematically determined. There is this small bump in wave 10 that, upon investigation, was the result of a decision made to include exclamation marks as their own separate token, and one particular answer that we show here Here we see the same test for the different question contexts, variants about the news versus politics. And again, we see the same qualitatively similar results where the null distribution, even its 99th percentile at about 0.9, is well below the observed dissimilarity, again demonstrating clear discriminant validity among all these pairs of questions. And again, we see this across all 13 waves. Now we turn to the more subtle issue of convergent validity. Recall our definition: a question demonstrates convergent validity if it provides more similar answers to questions intending to measure more similar constructs. Mood of the nation questions provide us with unambiguous theoretical expectations about similarity, namely that for any given question, answers will be more similar to questions that share one facet, polarity, temporal perspective, or contextual prompt, than to questions that share no facet. So, for example, we expect emotion questions that share polarity, that are both negative or both positive, will be more similar, less dissimilar, than will pairs that share neither polarity nor temporal perspective. Answers to the angry question will be more similar to answers to the worried question, which is also negative, than they will be to the hopeful question. And we see averaged across waves, the average dissimilarities are clearly different in the direction expected, and the number of matching waves for angry is 12 of 13, and similarly strong results for the other three emotions. Here we see the results again for contrast with the angry prompt, where our convergent validity test corresponds with an expectation that the solid line will fall below the dotted line. That is, that the dissimilarity with the worried question will be less than the dissimilarity with the hopeful question. And again, similar pictures for the other three emotions are provided in the paper and as extra slides at the end of the slide deck. Similarly, we expect similar results when the questions share temporal perspective, that is, they are both future-looking or present-looking, than if the questions share neither. So we expect, for example, angry to be more similar to proud than to hopeful. Again, in detail here for the contrast with the angry question, we see the same picture. The correspondence here is the expectation that the dashed line shown here will fall below the dotted line. We can also do this with the contrast between the specific versions of the angry and proud questions, asking about news and politics. Here we see the results for questions that share an emotion, that we expect those to be more similar than the pairs that share neither emotion nor context, and we get entirely consistent results. And for all 13 waves, again, the expectation is the solid line will be below the dotted line, which it is in all 13 waves. We also can expect that questions that share a prompt about the news or politics will be more similar than those that share neither emotion nor prompt. And again, we see strong results with the partial exception of the proud about politics question. This corresponds, as before, to the expectation that the dashed line will tend to fall below the dotted line. So we believe we've presented a transparent and replicable method to assess whether open-ended questions succeed in directing respondents to scan the most relevant considerations. This is analogous to the comparison of correlations among measures of constructs that are theorized to have ordered patterns of similarity as used in closed-ended questions. That FW variance can be used to assess both convergent validity, that similar questions receive similar answers, and discriminant validity, that dissimilar questions receive dissimilar answers. Finally, we note that this technique does not require human coders in the processing of open-ended test questions and is suitable for testing a priori expectations, including those that might be posited in a pre-registered design. Thank you very much, and look forward to hearing your comments.